Us for this week's Oregon Wild Wednesday webcast. I'm Chandra Legui, Oregon Wild Senior Conservation Advocate in our Eugene office, and I will be your guide through the webcast this evening. Tonight, we're excited to host Dick Hutto. Dick is an emeritus professor in biology and wildlife biology at the University of Montana, where he taught from 1977 to 2014. And most of his research was on the ecology of birds that colonize forests that experience severe wildfires. And he spent years doing public education on his research results. And last year, he got to do this in book form, publishing A Beautifully Burned Forest, Learning to Celebrate Severe Forest Fire. And that is what we're here to talk about tonight. If folks are new to this webcast or to Oregon Wild, I'll just give you a brief orientation before we begin. Oregon Wild has been working to protect and restore the wildlands, wildlife, and waters in our state since 1974. And today we have staff working in Portland, Eugene, Bend, and Enterprise on advancing protections for our wild places and rivers, defending environmental laws and policies that keep our mature and old growth forests standing tall, ensuring native wildlife have what they need to thrive, including burn landscapes, and building community support for our work. So for folks who bought tickets to our raffle tonight, we will do that drawing tomorrow and email the winners. We'll have a t-shirt from Oregon Wild and our speaker's book. So you can still get raffle tickets where you signed up for the webcast on the Oregon Wild website. Click on the event again, and you can buy tickets there. As we go along, if you have questions that come up during the program, you can use the little Q&A bubble that you should have in your Zoom interface, and then we will get to questions at the end of the program. But feel free to enter them in at any time, and that way you'll get in the queue. We will be sending out a video of this webcast tomorrow, and it'll be posted on our website and our YouTube channel, so you can share it. And we do have lots of other events coming up. No webinars planned, but we have an in-person event, going on right now in Portland about the roadless rule repeal. So you're not there if you're here. But we have one of those events coming up in Eugene next week on Tuesday. We have a bunch of trivia events coming up at breweries in Portland and Salem, and we are getting some of our guided hikes kicked off for the season in April. So you can find all of that stuff on the Oregon Wild website. So before I turn it over to our presenter, I did want to just acknowledge that the topic of burned forests can be controversial, whether we're talking about policy and management, as Oregon Wild often does, or ecology. And I will be honest, I got some pushback from a few people when we announced this webcast. How dare you think these forests are beautiful? And it's understandable given the way that our society has taught us that fire is a destructive, even catastrophic event. Fires in recent years have been more destructive to human communities than ever before. Not just in Oregon, of course, but in Oregon, from Lincoln City to Detroit and Blue River, our air quality has suffered from more smoke from fires. That's affected everybody. And fires have dramatically changed some of our very favorite places, from the Columbia Gorge to Opal Creek to the Rogue River. And given the snow year and ongoing below average rainfall in Oregon and many other places in the West, it's reasonable to fear a hard fire season ahead. So I just wanted to acknowledge that this talk might be challenging for some. But as we get into it, I want to emphasize again that the focus here is on the ecology of burned forests and what we can learn from and about them. We will also necessarily get into some of the play between ecosystem science and human management. But I hope that people will keep an open mind and challenge yourself to learn something new or examine your assumptions about burned forests during this talk tonight. So I will now turn it over to our guest, Dick Hutto, to share what he's learned over his many years of studying burned forests in Montana and beyond. So I will stop my share and turn it over to you.
Okay. Chandra, thanks for the introduction. That's just perfect. Let me open the share the screen here, and then just start with this. See if you get the picture there. Is that okay?
Yep, looks good.
Okay, good. Yeah, yeah, I'd like to thank Marina Ritchie too for getting a hold of Chandra and suggesting I I chew the fat with you all. And thanks, Chandra, for the invitation, and thanks to all of you at Oregon Wild for all of your work in protecting nature. It was an honor to be able to spend some time with you. So, just to carry on from where Chandra started, basically pick up right where she left off. You might look at the title of this book that I just published called The Beautifully Burned Forest and think, uh, what an idiot. This guy, he has a title that's like an oxymoron. How can a burned forest be beautiful? And what I want to do tonight is try to convince you that it's not an oxymoron. Um, we think that burned forests aren't beautiful because we've been taught they're not beautiful since the day we were born. Take a look at this. These are the kind of things that we were raised on. This shameful waste weakens America. Only you can prevent the madness, that kind of thing. On the right are actual pages out of the real Smokey Bear comic book. Smokey tells whoever, kids, whoever, them, how he hates forest fires, how they destroy his animal friends. I mean, this is the kind of thing that we grew up on, right? We were weaned on this right off the baby bottle. And here's signs that you can see on the road. Forest Service signs. This one on top. This is a more modern version of the same thing. What do you want? This, the green on the left, or this, the black on the right? Your choice. And the bottom one was right here in Missoula, Montana, a few years ago. Forest Service. Unfortunately, they can't run for their lives. The trees, and I'm going, what? Those trees can't reproduce successfully without that severe fire. And so we're not really talking ecology here. We're instilling fear of fire. Um, and the story today is morphed a little bit. Oops, sorry, morphed a little bit. I'm trying to move the. Here we go. There we go. Not all fires are bad. Okay, now we're beginning to say, yeah, some fires are okay. The ones that burn in the understory, leave the forest alone, replenish things, and everything's is healthy. And historically, this is the way most Western forests burn. Okay, so not all fires are bad. However, the story goes we've had too much fire suppression, which allows the forest to grow up and become very thick with fuel, which then burns severely, which then provides a forest that's destroyed. And so this too much fire suppression thing was a big story for probably as many as 20 years. However, more and more research came out. The more research that did come out showed that most forests in the West, there wasn't too much suppression. They're perfectly well within the historic range of natural variation. If you go to the very lowest elevation, very dry, open ponderosa pine forest, oh, okay, there are good data showing that suppression has caused understory to grow up, but not for most forests. So it is convenient that this just change to climate change. Oh, okay. Well, heck with suppression. It's climate change. Now the forest is really dry over here. And then a windy, hot, dry period comes and forests are burning unnaturally again. So we have historical forests on top and current forests, which are out of whack on the bottom for whatever reason. This has turned into the good fire, bad fire message. And you can see on the left here, that's good fire. The trees are standing, they're green. Fire's in the understory. Here's bad fire on the right. The good fire, bad fire story. And what's amazing about this, it's everywhere. It's not just the USDA, the Forest Service, even the Nature Conservancy, is in on this. Okay, so we're being told there's good fire and there's bad fire. We got to prevent the bad fire. Well, I'm here to tell you the real story is different from what we're reading here, what you've been told. When mixed conifer forests burn, they tend to burn severely. Historically, this has always been the case, I'll argue. And severely burned forests always yield mixed severity results. You can download any of the hundreds upon hundreds upon hundreds of fire severity maps out of land fire, and you'll see that any fire has about a third low, a third medium, a third high severity. Then it takes a high severity fire to get those three. You can't have a uniform low severity fire and get the mixed severity results. So severely burned forests not only give you mixed severity results, but they're magical places if you take the time to go out and look. And that's what I did for about 20 or 30 years of research. So not only is the scene here amazingly artistic, the smells are cool. They're up there. They're just great. The sounds are amazing. And even more important, there are plants and animals that occur in this particular environment that simply don't occur or occur rarely outside of this kind of environment. And that's really important. Severely burned forests are magical because many species just seem to appear out of nowhere. The richness of bird life is astounding. Here, I'm going to show you a little iPhone video that I took a couple of years ago right here next to Missoula, just 5 miles out of town. There's a big fire, the Miller Peak fire. And I said, I'm just going to go out there, see if there's any action. So here's some woodpecker action. Pileated, hairy.
It's pileated there. This
American tree-toad.
tree-toad, northern tree-toad. Hairy woodpecker there. And get back in there. Another hairy woodpecker.
This is all just standing in one place.
Hairy woodpecker there.
Wow, listen to that drumming. You see these woodpeckers? 1, 2, 3.
Tree-toads. Three tree-toads.
The fourth one comes in down here.
Tree-toads.
So you get the idea? These places are incredible. And the famous one, I think, is the blackback woodpecker. That's why I put it on the cover of the book. The blackback woodpecker is more restricted to burn forest conditions than any forest bird is to any other forest condition. It's more restricted than any other bird in the world to one forest condition. And it's almost entirely restricted to burn forests. And this has been known for a long time. In reference to blackbacks, Manly Hardy wrote Major Bendire in 1895. Specimens are so abundant in fire-killed timber areas, I once shot the heads off 6 in a few minutes when short of material for stew. And here are our own data on blackback woodpecker distribution across, I don't know, 20 or 30 different vegetation types. Every single vegetation type in the Northern Rockies we visited, we have hundreds upon hundreds upon hundreds of points in each of them, 20,000 points total, 20 or 30 years of data total. And basically, blackbacks are relatively restricted to burn conifer forests. I always tell people, look, if you show me a blackback outside of a burn forest, I'll give you $10,000. If you give me 10,000 for every one I show you in a burn forest, and I'll walk away a rich man. Now, where are the forests that hold this particular magic? It's the mixed conifer forests throughout the western United States. So that's basically a horseshoe shape that looks something like the green there. Not quite as far south as the picture shows, but most of what you see up through the Sierras into Oregon, eastern Washington, Idaho, Montana, down into Wyoming. Not so much into Utah and Arizona or anything. So it's the mixed conifer forest. By mixed conifer, I mean a mixture of tree species: ponderosa pine, Douglas fir, western larch, Engelmann spruce. Just get a good mixture of fairly large trees, thick barked trees especially, Douglas fir, ponderosa pine, western larch, and the magic happens. Post-fire explosion of woodpeckers is also restricted to relatively intact, densely stalked, mature, thick bark conifers. So by densely stalked, I mean not, tens of trees per acre, but I mean 100, multiple hundreds of trees per acre. So you got to have a pretty good densely stalked mature forest to get the real cool results that happen after fire. Look here, you can see the trees are all fed upon by woodpeckers that have been digging in there for beetle larvae. Take a look at this.
Oh, this is the hero of our story, male black-backed woodpecker. Jet black on the back with a brilliant yellow cap on top of his head.
Is that a cool bird or what? I mean, that blackback is amazing. The other thing that began to hit me after many years of working on this bird is blackback woodpeckers are so tightly tied to severely burned forests, they've even evolved cryptic coloration that let them match the black tree, right? The background matches as impressive as looking at the ptarmigan in snow on the right. Nobody doubts that it's been a long evolutionary history of that ptarmigan in a snowy background. You shouldn't doubt that there's been a long evolutionary history with that blackback woodpecker in black trees. And so all the data, all the facts seem to suggest that from an evolutionary standpoint, severely burned forests are absolutely natural. Things have evolved to the point where they now have traits that make them well adapted to survive and thrive in these particular environments. Here's another one. There are other species that occur almost entirely within recently burned forest conditions, and includes the little called the jewel beetle. It's a wood-boring beetle, comes in. It has evolved the special trait, infrared sensors on its thorax that can allow it to detect heat for up to 50 miles away. Now, this thing comes in and lays its eggs on trees that are now dead, right? There's good wood beneath the charcoal bark. And then the larvae begin to grow up beneath the bark. And so here's a nice morsel for a woodpecker, right? And this is what happens. And if you haven't been into a burned forest and stood there and started to enjoy the sounds, here's the sound of one of these beetle larvae beneath the bark. If I just took my iPhone, walk up to the bark, and here's what you hear. That's just standing right next to the tree listening. How about the fire morel mushroom? It also occurs almost entirely in severely burned forest conditions. Where are you going to get these mushrooms for your salad at night? Severely burned forests. So, in the places these things occur, the most specialized species, the ones most restricted to severely burned forest conditions, occur in the highest severity burns. So if you go from unburned to low to medium to high, more and more probability, higher probability of occurrence by the blackback woodpecker. Exactly the same with the morel mushroom, with research that came out of the rim fire by Andrew Larson and others. So the data are pretty clear here. Mixed conifer forests are transformed by severe fire. They're not destroyed, they're transformed. And it's not just those I've talked about. There are a lot of other species that have cool stories. Bicknell geranium, sit in the soil for 150, 200 years, waiting for intense heat for the seed coat to burst and to germinate. These boreal toads, that's a cool story. These things migrate into severely burned areas. In Glacier Park, they had to close the North Fork Road because cars were running over these things, and they didn't want that to happen. Anyway, you can go on and on. Bluebirds, we can go on and on with stories. I'm telling you, these places are magical. The lesson is historical fire regimes in most mixed conifer forests in the West are dominated by not low severity understory fire, but healthy doses of severe crown fire. This is what is the norm. So when we're given this good fire, bad fire message, I think we need to take an ecological perspective and say, I'm not too sure about this. I think the one on the right is actually a pretty good fire. And the one on the left is actually pretty unnatural and very rare. The mixed conifer forests don't tend to have low severity understory fires. Open grown ponderosa pine, sure. So we need to change the narrative. And we change the narrative by returning to lessons taught in Ecology 101. If you take any ecology class, one of the sections, the major sections, would be disturbance ecology. And that can be disturbance from storms, hurricanes, blowdowns, fires, volcanoes, beetle kill. And what's amazing about disturbance is if it's severe enough, you get this transformation into a series of forest types that develop back to what was there before the disturbance came along. So disturbance is a natural ecological process that triggers succession, and that successional series creates habitat diversity. So there are critters, plants and animals occur in this early stage that don't occur anywhere else. There are other ones, special uh, critters that occur in this age, 10 to 20 years, and some in this 20 to 40 year, and some in this 50 year to 100 year, and some. So you have all the stages with all the different species as you go through succession. You need disturbance to get all the different phases of forest types. And what's amazing is it takes a high severity fire to get this succession to kick in. That's the ecology. Low understory burns that keep a steady state forest in play are not what I'm talking about. You don't get succession through understory burn. And the way succession ought to be depicted in a textbook is probably a circular thing instead of a straight line. Straight line seems to imply you get to an end point, and that's the end all be all, and that's the goal. No, no, that's not how the world works. It's a circle. There's constant disturbance. And so we get mature forest and old growth forests that get disturbed by severe fire. Then you get blackened standing dead forest, right, that has special critters in it. Then broken snag forest 10 years later, maybe, where notice how all the trees are broken now? That's a very special time that has very special species starting to come in. Then there's broken snag shrubland that comes. And then eventually you get back to young forest, mature forest, and old growth if it goes that long. Notice as we get to these early post-disturbance phases, you get the fire morel and the jewel beetle and the blackback and the mountain bluebird. And if it gets a little older and the trees break, white-breasted nuthatches show up like, holy cow, Williamson sapsucker, Lewis's woodpecker. It's amazing. Then you go a little more and you get, oh, lazuli bunting and orange crowns and snowshoe hare and lynx and all sorts of other things. So all the stages of succession are really important to maintain in our forests. If you deviate from that line by clear cutting, prescribed burning, that kind of thing, you're going to get succession, but it's not the same picture that you get on the outside circle here. You're cutting off, you're short circuiting all of the critters and the special conditions on the outside circle if you mess with that disturbance process. So severely burned forest conditions are therefore not only historically natural, but they're necessary. They're a necessary part of our mixed conifer forest systems. So the next time you see a fire burn up in the local mountains and you see this blackened thing here and the newspaper says, oh, wow, oh, well, wow, that fire scar up there. It's not a scar. It's a beauty mark. So now I'll get to the second part here. Let's see, how am I doing on time? Okay. Does land management serve to maintain the ecological integrity of disturbance-dependent forests? And I'm going to argue not exactly. There's three phases of land management I'll talk about: activity before fire, activity during fire, and activity after fire. Here's before fire. Here's what you'll read in primary literature. Here's from an article. They'll argue ecologically managed forest here is thinned, burns in the understory, and there you have a nice forest. Here's a fire suppressed forest. This is the story I told you about earlier. But the argument I'm going to make is this is not ecologically managed. This is ecologically managed. The one on the left. The one on the right is mismanaged from an ecological standpoint. And here's another from another professional paper. There's route A and route B. Route A, you thin the forest, it burns in the understory, and it's heaven. You go in the other route and you don't, let it burn severely, and it's death and dead fish floating down in rivers. And, it's another whole story, but fisheries are never better than after siltation process and reorganization of streams after severe fire. And of course, it doesn't show the tons and tons and tons of species that occur in this sort of blackened forest. Also, the species that occur over here in this artificial forest with the artificial understory burning are not spotted owl, I'm sorry. Neither are they blackback woodpecker, I'm sorry. The other problem with cutting before fire is if you thin the forest and then it burns, and it will because all forests burn when the conditions are such that the big fires occur. 98% of the fires occur when conditions are hot, dry, and windy. And they'll burn. But you might say, oh, well, at least you get your burned forest, right? And I'll say, no, because it's not dense enough. You've thinned it. Now the density's too low. Now the magic isn't there. Now those woodpeckers and all the other species have densities that are much, much lower. And this has all been published. So what we need to do is have our managers make sure that all successional stages, natural stages, are in our forests. So you need to go to your district ranger, say, could you please show me a map of all the stages of succession, natural succession, not artificial, and how much is in each stage so that we ensure that we're maintaining every stage of succession in our forests out there on the landscape. Timber harvesting, should always be conducted in moderation, or you're going to cut off that outer part of the circle. Our public lands can certainly provide a bit of timber, but never be treated like private commercial timberlands. Come on, we can't be excessive there. We have to leave a lot of mature and older forests intact so that they're allowed to burn and become magical after the fire. Okay, then the second management activity, I'll talk about activity during fire suppression. And this is fairly simple. I think we're just going a bit overboard with our suppression. And the reason we go overboard is we've been taught that, that fire is really, really, really scary. And maybe it's good to demonize fire because that generates public support for suppression, which allows us to keep fires from getting big. But suppression doesn't do that. The most amazing paper ever published on fire suppression effects is Johnson and others, 2001, in Ontario, in suppressed areas and areas where there's no fire suppression. When you suppress fires, it's the light bars here, the number of tiny, tiny areas that burn go way up. So suppression is amazingly effective. 98% of the fires are put out, and they're less than 10 acres, less than 1 acre, most of them. However, did you then prevent the big fires from happening? The answer is absolutely not. There's no statistical difference in the number of large fires in suppressed and unsuppressed areas because large fires burn in conditions that are dictated by the weather, not by fuels. So large severe fires are inevitable. Fire suppression doesn't put a dent in the number of large fires that burn. Also, large fires don't really pose the kind of safety threat that we all think exists. Here's data. Here's a picture from a video by the research biologist Jack Cohn at the Forest Service Fire Lab here in Missoula, Montana. He's published amazing stuff showing basically that walls of flames can be 250 foot tall, 40 feet from a house, and the house is unfazed if it's well prepared. So you can have your homes and the immediate surroundings be defensible, basically, and be relatively safe. So the fires are not as risky as we're making them. Certainly the forest fires. When you get winds blowing 60, 70, 80, 90, 100 miles an hour, and embers are blowing, that's the main threat. And this is what takes out places like Palisades and other places, which is not a forest fire at all. Anyway, my conclusion with firefighting is we could probably relax a bit with efforts to suppress all fires, especially as we get into the outback. There's no reason to be out there. It's restoration in progress. Then finally, there's activity after fire, post-fire salvage logging. This one is unambiguous. There's not a single kind of management activity that is as negative, ecologically speaking, as salvage logging. Every single paper ever published, and there are lots of them, show that the species that most depend on severely burned forest conditions are negatively affected, if not disappearing altogether. I once wrote, I'm hard-pressed to find any other example in wildlife biology where the effect of a particular land use activity is as close to 100% negative as is the typical post-fire salvage logging operation. I mean, it's bad. And so the conclusion for post-fire salvage logging, it's fast. Burned forests harbor unmatched ecological value and should be the last, not the first place we go to cut timber. I even put it behind old growth forests. It's more valuable. It's more amazing. It's more magical. And so We need to be changing the story with salvage logging, especially when we have our elected officials introducing legislation to expedite salvage logging, to waive environmental, review, et cetera, et cetera. So when you read a Forest Service scoping document, what they always say is, oh, we need to recover the economic value of forest products in a timely manner and contribute to employment in the local communities. But and then they'll also say we need to plant too. So now it's becoming tree farms. This is our public lands. This isn't commercial forest land. Why not just go get some green trees if you really lost a bit of your timber? There's plenty of green trees out there, and green trees they grow, right? Go get a little bit of timber. That's fine. Even more important, why not take advantage of the ecotourism boom that happens associated with fire? After Yellowstone burned in 1988, never were there more visitors than the year after that fire. It was right away with 1.5 million or something like that. I mean, I always say Yellowstone turned from the most boring park in the nation to the most interesting park in the nation overnight. And so you can make a lot of money by filling your hotels and restaurants and things, catering to birdwatchers and others that want to see things that you can't see anywhere else. So when a fire burns, I think we need to learn to celebrate the event. This is a beautiful picture of the scapegoat wilderness. We should be dancing in the streets. We can see things we can't see anywhere else. We need to begin to learn about the wonder of severely burned forests. And so now you know why it's not an oxymoron to be talking about a beautifully burned forest. So that's basically my story. Love to hear what y'all think. If you have questions, see if I can answer them.
Yeah.
Don't know.
Yeah, great. Thank you so much, Dick. Yeah, just a reminder, if folks have, you can unshare if you want, Dick.
Sure.
Um,
Oh yeah,
uh,
let me get back to that. Oh, there it is. Okay, there it is. There
If
we
folks
go.
have questions, please use the little Q&A bubble, and we'll get to those in a couple of minutes. But before we do, so yeah, you can take a moment to think about it,
Yeah, yeah, yeah.
questions that you might have. And before we get to the Q&A, I'm just gonna take a few minutes to connect a lot, actually, of what you just talked about to Oregon Wild's work. Um, and again, give people a chance to think about
Yeah,
where
yeah.
it
No
fits.
problem.
So, I'll start with a personal connection. So, as it sounds like getting into burn forest ecology was really about birds for you. And I will say that for me, I think it was just my inherent fascination with nature. And some good teachers. So I attended the University of Oregon for my master's degree, and I got to take a forest ecology course and do several field trips to burn forests, including in the Warner Creek burn near Eugene and in Southern Oregon. And so I just found it so fascinating to see the wildflowers and shrubs and the young trees coming up, with the charred snags and looking for signs of wildlife everywhere. So I totally agree that they're kind of magical places. I might take issue with, being better than old growth because I did write a book
Right,
about
right,
old growth, but
right. I expected that.
But
Right.
no, but every forest, as you said, has burned and will burn. It's a vital part of these forest ecosystems. So, everywhere that I go, and I've traveled all over Oregon, I love to look for signs of past fires in the forest that that I and Oregon Wild works on. And that's in all types of forests. So coastal redwoods, the high Cascades, the dry pines along the Deschutes River, as well as the mixed conifer forests of like the Blue Mountains that you were talking about. So those
Mhm.
are different types of fire regimes in many places, like you were saying. But the signs are really everywhere, and they're really diverse. Some are really subtle and maybe happened, a century ago, where you find fire scars on a Douglas fir in a dense, moist forest. Um, find signs of
Hmm.
wildlife, signs of mushrooms, these diverse patterns in the landscape that, you might not be explained in any other way other than, a mixed severity fire, for example.
Hmm.
But other
Yep.
other signs are more jarring, and even with the appreciation that I've learned, that you've learned, that we're sharing with people, when fire affects a favorite place, it can be really jarring. So this is Waldo Lake, and the Cedar Creek fire that burned the west and north side of the lake and the roadless area that surrounds it. And I got a chance to fly over that fire not long after it went out, like the year after. And even then seeing, this mixed severity
Yeah. Yeah.
in
It's amazing.
places. In some places it reburned over a previous fire and it's just like literal toast. So, it can be emotional to see that. But yeah, in all of these experiences, I feel like the science is just so clear that fires always played a role in these forests, and it develops the complexity and biodiversity that we celebrate in our
Hmm.
advocacy. But yeah, at the same time, humans have dramatically changed the role of fire and just how these landscapes look. And so, yeah, I just wanted to go over a couple of things that we're dealing with as far as that landscape goes today. So we know that policies that eliminated fire practices of indigenous people, that required aggressive fire suppression on public lands, and that removed the largest and oldest, most fire-resistant trees, especially in the moisture forests, have led to these conditions of, uniform tree plantations that are much more prone to intense fires. That's not really natural. And in some places like these dry ponderosa pine forests that we have a lot of in central Oregon, where low severity fire was a natural fire regime, the small trees were cleared out on a pretty regular basis. And today, with fire suppression and grazing, those young trees have grown in. And so, again, we have just a different condition than we would have had with natural fire regimes. And, all of that's on top of a warmer climate that's, leading to hotter, drier summers that are ripe for those intense, fast-moving fires, like you were saying, the intense weather conditions. Um, and yeah, things like post-fire logging and yeah, I was going to say that. Things like post-fire logging are just making things worse. So yeah, in recent years, there has been progress made in understanding fire ecology, like, people like you, Dick, spreading the word, good films being made, lots of research being put out there. And there's been progress in working to implement effective ways of better protecting our homes and communities, like, like Cohen's research, and then also reintroducing fire in especially ecosystems with that low intensity fire regime. But unfortunately, all of those policies that have led to kind of our unnatural conditions today uh, are being doubled down on in the current administration. So today, we're seeing, even though, progress was made over the last couple of decades in understanding, but today what we're seeing is that, this administration is insisting that more roads and more logging will make our communities safer and fix this whole fire problem, even in the backcountry and in old growth forests. And in fact, the opposite is true. We know that more logging is just lining the pockets of corporate interests, and more roads in the backcountry mean more fire starts, more fire ignitions. So that's not really a solution. We're seeing this administration go after protections for the wild places that we have left, where fire could play a more natural role and burn and create some of this amazing landscapes. So the proposal to repeal the roadless area conservation rule could open up millions of acres of forest to more roads and more logging, leading to more fire starts and more conversion of our natural forests to those fire-prone plantation conditions. They're also going after our most fire-resistant and resilient forests. So revising management plans to allow for logging older forests that are currently protected, larger trees, like in Eastern Oregon, where we currently have a rule protecting 21-inch diameter trees and larger. That could be changed under these management plan revisions. You mentioned some of the streamlining, I think, of environmental review. So doing more categorical exclusions to streamline how fast environmental analysis can go so we can log more and faster, both through legislation and through policy changes that's happening. And then, of course, just flat out mandates to do more logging, while at the same time cutting agency funding and staff and reorganizing, so that there's not very many people left who can do some of the work that's not logging, right? So it's all being funneled towards that one activity that's changing our forests in dramatic ways, as opposed to research and analysis and restoration of habitat and use of fire in beneficial ways. And then, denying climate change and climate science. So we won't be addressing those underlying causes of hotter, drier conditions anytime soon. And, there's still barriers to limit indigenous burning and restorative prescribed burning in some of those places that where it could be really useful. So all of that's going on. Like I said, doubling down on failed policies. And so we've got a lot of work to do. And those of you on here who are familiar with Oregon Wild's work, this is a repetition, but we can combat many of those bad policies through a lot of the work we're already doing. So defending the roadless rule, we don't have a lot of natural areas left where fire can have these beneficial effects. So if we maintain the protections for these wild places, then we give those forests a chance. So we're working to protect mature and old growth forests and all of these different forest types with different fire regimes. It will help mitigate climate change and save the forests that contain the most biodiversity. We've been doing that through generating thousands of public comments during opportunities to weigh in on forest plan or management plan revisions. So many of you may have commented on the BLM plans or the Northwest Forest Plan, and you can look forward to soon commenting on plans for the Blue Mountains in Eastern Oregon. And then we're also supporting home and community protection that's common sense rather than logging in the backcountry. So even in bills at the state level, like HB 4134 that just passed, that's the wildlife bill, the wildlife funding bill that many of you have heard so much about recently, that included funding for programs that focus on home hardening and community protection that we think makes a lot of sense. So lots of things, efforts going on that we were already supporting, but really ties into this idea of celebrating these natural forests and protecting them. And what you can do about it, because like I said, we're doing a lot as an organization. But if you're a supporter of Oregon Wild, thank you. You can keep learning more. We have resources on our website. If you search for fire under resources, you'll find past webinars and blog posts and other sorts of links where you can learn more about fire. Obviously, read Dick's book. That's a good way to learn. And we also have actions on our Action Center on the Oregon Wild website for doing things like commenting about this roadless rule repeal and other things. So I will leave it there and go to what looks like a steady stream of questions that have come.
Yeah, there's some good questions.
Okay, you've been looking at them.
Interesting.
I haven't been looking at them. So
Yeah, I just started scanning. Jim Lebo
okay.
has several. Do I push on answer live or just talk?
You can just talk and pick
Yeah.
one to start with, and I'll start
Um,
going through too.
yeah, okay. Let's see. He's talking about, is there a source of data showing which species are present in which stages of succession? It's amazing. Relatively little work after the early stages of fire. So there's been quite a few studies on, the 1-year-old, 2-year-old, 3-year-old. But once you get to 5 to 10, 10 to 20, no, there isn't a lot. And especially comparing a 10-year-old or 20-year-old forest that's result of clear cut, a result of shelterwood cut or a sea tree cut or some other kind of thinning versus one from fire. I can tell you, I have published stuff on comparing the early stages with all kinds of land use that are early stage after fire, and it's like night and day. A burned clear cut is not anything like a burned mature forest. A burned thin forest, I told you, is not anything like a burned mature forest. So there's some real differences. But as you get older, in 10, 20, 30, 40 years after fire, almost no data that I'm aware of. So it's wide open for students who want to, research projects. I mean, it's really an interesting question. How important is natural succession? You were talking about things you're seeing when you wander around burned forests, Chandra, that, oh, I see these things, years and years and years later. I don't know how important those things are. We see these snags that last forever. How important is it to have standing dead that doesn't get salvage logged
Mhm.
50 years later? And these are the kind of questions that just, as far as I know, no data on. Um, and so I suspect they're important, and I suspect that natural succession thing through undisturbed forest is going to produce much more magical communities than ones that have been modified.
Mhm.
Let's see. Many managers put humans at the center of forest ecology. Forests need us and need our active management. What's your take on this? Eh, you know, I, I'm skeptical. I don't think the forests need us all that much. The forests seem to do just fine on their own, it's usually a utilitarian thing that we worry about. There's beetle kill. Doggone it, it's ruining the timber, value. There's a fire. Doggone it, we're going to lose some timber. There's whatever. And it's utilitarian. It's not ecosystem management. I don't think the forest needs us to help it along. It's doing just fine. It's done fine for, 500,000 years. It's probably okay without us. Um,
Could I just maybe add? I mean, I think a lot of people are talking these days about the use of fire to manage landscapes that Native people had,
yeah,
and that's largely been removed from landscapes. And my understanding is, and I mean, it's different everywhere, right? Is that a lot of that was probably not at the scale that we're seeing things like timber management on our national forests. It's managing forests with fire, or in other ways at much smaller scales. For hunting and for
yep,
getting food to grow.
yep,
And so when I mean, so that definitely
yep,
produced a different type of forest, or maybe a different patches of in the ecosystem.
yep.
But when you're
It's
looking, but it's different at different scales.
yeah. And so that's the big point. So my take on indigenous burning is, as Bill Baker has shown in his book on fires in the Northern Rockies, very localized in the big scheme of things. A. B. It's utilitarian in purpose. The Native Americans are not doing ecosystem management. It's for growing, it's for driving game, growing the kind of plants they'll want for food or for baskets or whatever. It's utilitarian. And so, and so to say, oh, wow, everything's out of whack because we're not doing what other humans did, you know, it's hard to say these things because then you're labeled as a racist, right? If I say that, it's like, oh, come on, they're more, just as utilitarian as we are, the Native Americans, and just at a scale that's much, 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 much smaller because that's all they could do. And so it's localized. It's around areas where they were settled, and they opened things up, and it was easier to get food and easier to get supplies and things for baskets and the like. So, if you want to restore those things for that purpose, okay, but that's what it's about, I think. It's not about ecosystem management.
Mhm.
Okay, let's see. Forest Service is largely centered in the idea of producing board feet. Can you talk about how ecology can mess with mandates managers have? Um, Ecology doesn't mesh with the mandates managers have. That's my answer. The Forest Service is not driven by ecology. It was wonderful back in 1990, late 80s, 1990, when ecosystem management became a fad and things were looking pretty good. I thought, whoa, this is amazing. The Forest Service talking ecosystem management. What do we do, to sustain a system that sustains us all? and not use it in a way that destroys the ability of the system to supply whatever we need, whenever we need it. And I think that ought to be what we do, but they're not trained as ecologists. There are too few ecologists in the Forest Service, too many timber growers, and that's the problem. And I think if we had more ecologists running the show, we wouldn't be talking about all these problems. What's your forecast on impact on spotted and barred owl? I have no idea. Okay, don't know. Sorry.
It's
Sorry.
not in your neck of the woods, so to
No,
speak.
right. I just don't know about them that much. So lots of woodpeckers burned area. Oh, that's good. Nelson has seen a ton. Cool. Thanks for all research. Cool. Thanks, Amy. Uh, oh, this is cool. Carly Ritter, why is your understanding of fire science so different from Forest Service and BLM? Well, that's a cool question, but I think the answer is I'm an ecologist. They're not ecologists. So I go back to what I just said. They're not hiring ecologists and they're not being run by ecologists. Is the head of the Forest Service an ecologist? No. And so without ecology, you're not going to see these things that we talked about tonight. If you're the fire scientist, you're not going to see these things that I've been talking about tonight. You can't see the forest for the trees. It's basically it's a problem unless you're an ecologist and understand ecology. Managers of drafting plans do treatments in wilderness. Oh yeah, and this is sort of in the roadless thing. I think one of the things with the roadless that's a problem is the data I showed that uh, we aren't good at suppressing large fires. So don't tell me you need to go in, put roads in to help with fire suppression. You don't suppress big fires anyway. Show me the data that you suppress. You don't. When big fires burn, it's weather, it's temperature, humidity, and wind that determines those fires. And those are times when we pull everyone off the line. So we're not doing anything with suppression anyway. Now don't go into roadless area and tell me you need to go in there and do suppression. Okay,
Yeah, and then, there's a whole bunch of wildland firefighters who have become outspoken about,
yeah,
retaining roadless protections, and
yeah,
they're
probably,
dangerous places to send wildfire or firefighters
probably,
into.
yeah, probably Tim Ingalls. Yeah.
Mhm.
Okay. Uh, I'm hearing so many people trying to equivocate logging with fire disturbance. No, it's not. Big differences. Oh, well, I've got a lot of papers on it. I suppose you could look them up. Yeah, they're like night and day. You're not going to see blackback wood. Let's just deal with the blackback woodpecker.
I mean, you take out all the snags, right? I
Yeah,
mean,
you take out
taking
the
out the
snag.
dead
Yeah, yeah,
trees are really important.
yeah.
So
Even if you do minor logging. So Vicky Saab is the other person who's spent most of her career studying fire and birds and fire. And she finds that there are some species that go up when you salvage log, and that kind of thing, but they're not the fire dependent ones. They're not the ones that depend on and are fairly restricted to burn forest conditions. You can always get a trash bird no matter what you do. You can drive a car through a forest and wreck it, and you're going to see something respond to it positively. And so, yeah, no, there's a lot of papers showing that they're very different. So we cannot emulate fire disturbance. So Jerry Franklin at the University of Washington is always one to have argued, let's emulate nature. Let's cut patches in the forest, make it like a Vic severity fire. Sorry, Jerry, it's not like night and day out there with your artificial forest versus a naturally fire burned forest. Just go look at the data.
I might say that, and this isn't in burn forests, but introducing some diversity and some patches into already managed forests is going to be better for it.
Probably,
That's something that I think, maybe gets lost in what Jerry says sometimes is,
yep. And it may
um,
burn more patchily, yeah, but it's not a substitute. If you went in and got data on the critters that were there, you'd find that they're different. They're different. Um, not that different, but they're different.
mhm.
Here's an anonymous. It appears current hotter, drier climates, burning bigger swaths, reburning same areas, cutting off. Isn't this cutting off natural regeneration process? Yeah, these are research questions that aren't very clear at this point. We know they're not burning hotter. If you put a thermometer in there, it's no different than it's ever been. So the intensity is the same. However, the proportion of land that burns severely is slightly higher in the lowest elevation forest, but no different in this mixed severity forest. They're burning like they always have. The total area burned is much larger on average. So yes, we're having larger fires. Okay, now we got an issue. What do we do about it? The reason is pretty clear. Climate change. If you want to solve the problem, you deal with the problem, and that's climate change. You're not going to solve the problem by thinning a forest. That's not going to solve it. So yeah, they're burning in a way that's different than it's been before. And for blackback or something, that's cool. But if we don't like it, human beings, and if we think it's a little much, well, then we ought to do something about the problem, and that's climate change. Okay, one concern a lot of us have was a new reality of fire. Lack of tree regeneration. Yeah, yeah, yeah. It's another good point. Eric Butler says, so now when a severely burned area burns, shoot, the tree recruitment isn't as good as it used to be. Once again, my answer would be that's a climate change problem. Not a, that the fire is perfectly natural. The fact that we're not getting the same kind of regeneration that we used to is a climate and global warming problem. And yep, we're not going to get the same succession that we used to get. And yep, the world's changing very fast, very fast, faster than I think Paul Ehrlich was afraid of with that bomb. We're exploding so fast and changing so fast. It's scary. But there's not much we can do about that. We're not going to solve that problem by planting trees and making tree farms.
Right.
And that's what most people think. Oh, gee, isn't they're not going to regenerate? We better start planting trees. Oh my God, no.
We could follow up to that climate change point. Didn't you say we've always had high severity fires? So how is climate change changing that? Just to clarify that.
The probably larger on average. So we've always had severe fires. Look at 1910. Look at come on. Look at Yellowstone, 100.5 million acres. Yeah, yeah, yeah. We've had huge fires forever, and we always will. But we have more of them now, and they're slightly larger on average because the world's getting warmer. And that's tells you why you get these fires. It's not fuels. It's the warmth. It's the temperature, humidity, wind. That's what's causing fires that burn 98% of the land.
And the reason why we need to be focusing on our homes and communities because we've been encroaching, right, into,
Yep.
further and further into the areas that are burning more because of climate change. So,
Yeah.
that's
And
just
that's the good news from Jack Cohen is that, if we take care, we can probably be a lot safer than we think we could be. Just your house itself and the 100 feet around it seems to be what makes a difference in the probability it's going to burn or not. Because what it is embers blowing in, and we have junk piled up against the house and in the gutters and in the vents and things, and it's just not a good idea. And we get kicked out, so they evacuate. So you can't take a garden hose and help save your house. This is some real things to think about here. What it takes to defend our houses and live amid severely burned forest conditions.
If you want to just take this last one about
John,
differentiating.
which one? John Herbert?
No, the anonymous one, I think.
Climate change? Oh yeah.
Oh, actually, you know what? Yeah, sure. Let's take that last one from John.
John
Just
Herbert, building force seems to risk the buildings burning if we allow fires that happen. Tents that we move out seem more suitable. Does building survival require large fire suppression or only small area with little effect elsewhere?
Yeah, I guess I'm not totally
I'm not
following you.
sure. Does building survival require large fire suppression or only small area with little effect? I think the latter, only small area with little effect elsewhere. And so Cohen's research has shown attention to your house itself and up to 100 feet away, you can feel pretty good, I think, and even live out in the woods. But notice most cabins out in the woods aren't anything like that, and they're burning up.
Right.
Yeah.
Okay, well, I'm going to ask you one last question. And just because I want to know, I mean, you obviously seem enamored with the blackback woodpecker, but other than that, what is the coolest animal that you've ever seen in a severely burned fire? Or
Coolest
severely
animal?
burned forest, sorry.
Geez, I don't know. That's a weird let's see the coolest animal. I mean, geez, I just don't know. Nothing unusual. It always is exciting to see something like Lewis's woodpecker, that come in these huge snags that are broken top, and there's this watermelon bird, it's like, oh my gosh. And Williamson's sapsucker eating the ants that come in, 10 years after. The color of the male Williamson's is just amazing. But, I liked, my favorite probably little jumping spiders. So I don't know anything about them.
I love finding insects in these
Yeah,
places.
yeah.
Yeah. Cool. Well, thank you so much for your talk tonight.
Sure.
Lots of great questions. Thanks
Yeah.
everybody who asked those and who are just as fascinated, it appears, with this topic as we are here. So thank you so much, Dick.
All right.
And everyone have a great night.
Great. Well, thanks a lot, everyone.
All right. Bye.
Bye.
Take care.